Hello. Hello. Hi everyone. Good evening and thank you for joining us today. Today I stand with in front of you with great pleasure to revive the Tech Container. Tech Container has been a platform in Navis and Caleris for the past 3 years, and we use this platform to share the latest trends in the tech world. Before introducing the 22nd session today, I would like Lax to say a few words.
Thanks, Monica. First of all, I think it's an awesome thing to revive this. I've been asking people to do it, and so kudos Indranil and team, whoever is doing this. It's a great way to keep connected with the tech community. So thankful for Someshwar, who has joined us. I think he's from Bangalore, is he? So Someshwar, we are really looking forward to it about cloud native apps. So we have been using these for a long time, but really good to hear from someone who is working on it. And I think, just enjoy, learn, and I would encourage or each one of you to just pay attention as much as you can and learn from Someshwar. So all back to you, Monica. Thank you.
Thanks, Lax. I'd also like to give a small introduction about the speaker. Someshwar has 4 years experience as staff engineer at Bazaar Voice and a total of 14 years experience in the IT industry. Today, he's going to talk about how organizations being cloud native is transforming the concept of software development. Someshwar, over to you.
Hey, thank you all. Thank you for having me. Uh, it's really honor to present in front of you all. Let me share my screen once. I hope my screen is visible. So let's start with the today's topic, which is cloud native architecture, how it is transforming the software world and software development. So in today's speech, I will tell you how cloud native applications are like, I say the superheroes of software world. So they are the awesome power of the cloud, where we are given space. If we are given space to do our things right, we perform well. Similarly, I say if cloud native setups applications are not tightly chained down anymore, and they're free to change themselves and communicate nice with other systems, and it's basically making life easier for everyone.
Hi, Someshwar, your screen is not being presented yet. So can you check on that?
Sure, 1 second.
Yeah. It's presented, but you're sharing the meet. Can you share the PPT? Yeah.
Yeah, can you see my screen now?
Yeah. Yes.
Okay.
Thank you.
So I hope it is visible now. So in today's speech, so I'll tell you, basically, I'll try to answer 4 questions. What is cloud native, and where are we today in this cloud native world? Like how businesses are growing along with cloud native, and why? Why they're growing along with the cloud native ecosystem? And then last one is the how the cloud native adoption is really possible for any organization, small size, mid size, or even the big size organizations. Then I will probably talk about few challenges of cloud native applications. So without further delay, let's move on to our agenda. First one is why, what is cloud native? So the CNCF, actually Cloud Native Computing Foundation, this is a Linux Foundation project. It was founded on 2015, and this was founded to help advance container technology and align all the tech industry around its evolution. So according to their definition, so a new computing paradigm that is optimized for modern distributed system environments capable of scaling of tens of thousands of self-healing multi-tenant nodes. So, you know, in cloud computing, multi-tenancy means basically that multiple customers of a cloud vendor are using the same computing resources. So despite the fact that they share the resources, cloud customers are not aware of each other, and their data is kept totally separate. And multi-tenancy is a crucial component of cloud computing. And without multi-tenancy, it would be the overall cloud concept is far more less practical. And as you can see here in the picture, multi-tenancy, a good analogy of multi-tenancy is how we are sharing our apartments, right? So in our apartment, in particular apartment we are living, we don't share anything inside our apartment, and we still use certain common places like a gym and the clubhouse, etc., etc. That is, uh, this is a good analogy of multi-tenancy, how shared resources can be used across the applications. So, multi-tenant architecture is really a feature in many types of public computing, including IaaS, PaaS, SaaS, containers, and serverless computing. So the next question now, that where are we today in this cloud native world? As you can see, Gartner research has predicted 95% of the adoption. That means it is actually 30% up from the 2021. And many small and medium businesses and big organization has adopted cloud native technology to develop their software, to build their software, to ship their software. So I'll present few statistics over here now. As you can see, this I have also given the link, the source. So the small businesses actually, so cloud native is not only for the big guys actually. They're really the toolkit for any businesses, no matter how small it is. Cloud computing is all about helping the stuff every business struggles with, right? So they help with being flexible, being tough, and of course being cheap. So for small guys, as you can see here, cloud-based businesses like accounting, sales, e-commerce, then the security, password management, and web conferencing, video conferencing, everywhere they have SMBs has adopted more than 50% SMBs have adopted cloud native technologies over here. And everyone has responded to a survey which was conducted a few years back. They said they're extremely likely to use the cloud native, any cloud infrastructure and cloud native framework. So that is for the SMBs. And also, as you know, all the big guys, big companies, big organizations across the world are extensively using cloud native architectures, like name it, Microsoft, Amazon, everyone. So another few DigitalOcean actually participated, many organizations participated one survey of DigitalOcean, and they have responded to their couple of questions, and it was very much evident that how much they're likely to use cloud native architecture. Like more than 50% of them saying that they're very happy with cloud native architecture. Be in any question. So there are certain questions I have just prepared, and their statistics I have posted here, and also I have mentioned the link of that survey. You can check out whenever is in your free time. So everyone is saying leveraging cloud providers, automatic scaling features, the in-house management. Everywhere they're more happy with adopting the cloud native architectures in all of them, all the setup of their infrastructure. So this is what I wanted to show, that where are we today currently in this cloud native world. The small guys, the big guys, everywhere they're using cloud native across the world. There are certain statistics over here. Now the question might come that why they're adopting cloud native? What is there inside cloud native architecture, or why the software development has been easier using cloud native architecture? So this why I'll try to answer now. So first of all, going cloud native means you can get your products out there faster. So picture this: you are a manufacturing company, and instead of waiting around for scheduled maintenance, you can jump in and fix things up based on the real-time needs, right? Or imagine you are in healthcare and you can get the right medicine to the right patient exactly when they need them, potentially saving their lives. And for all the retail guys out there, so cloud native setup let you slice and dice your customer data for super targeted marketing campaigns. So these are some extensive feature of cloud computing nowadays. And the next is onto making our products even better. With cloud native setup, you have got the power to roll out new features quicker than ever before. Like take Netflix or Amazon Prime, for instance. They can recommend perfect show or product based on your interest, thanks to their cloud native architecture. So plus it's like having a magic button for your development team, giving them the tool to automate tasks and scale up without a problem, right? So, and here's the important part: going cloud native means you are not stuck with the stone aged outdated practices. Your architecture becomes this self-improving, cost effective powerhouse actually. So basically there you have it. Going cloud native is not just about keeping up with the times. It's about giving your businesses the speed, the agility, the smartness it needs to thrive in today's fast paced world. So now I will dig in. So this is the why part of it, like why cloud native. Now how cloud native, how we can adopt cloud native. So what is, how we should do that, how we should approach that, right? So before that, think of going cloud native is like upgrading your old car to a futuristic model. It's not always easy to switch, I agree, but sticking with the old ways will always hold you back. So, so what's the deal with this cloud native? What's all about building your application specifically to the cloud environment? So we have three mottos actually: build to the cloud, uh, for the cloud, and take out all or most of the benefits that a cloud service provider offers. So to do that, we have certain target types that we have now coming. I'm coming towards more on the technical side of it. That what are the things we need to understand before we move to the cloud native architecture? One is, of course, you've got the virtual machines, then the containers, and then application platform as a service, and then the serverless functions, right? So each one offers its own set of perks and possibilities, from flexibility to scalability. So if you talk about the examples, for virtual machines, you have got options like AWS, Azure, GCP, Oracle Cloud, IBM, and containers can be hosted on platforms like Docker, Rocket, Runc, or LXC, and application platform as a service. So that can be like Heroku, Bluemix, and Oracle's application container. And last but not the least, serverless functions, which is can be found on the platforms like AWS Lambda, then Bluemix, OpenWhisk, then Microsoft Functions, Oracle Functions, Google Functions, etc. So now to understand how we should adopt the cloud native, we have to understand the pillars of the cloud natives. So broadly, we can categorize the pillars as the four pillars. That is DevOps, continuous delivery, microservices, and containers. So generally, it's based on the principle of CALM, CALMS. So the ideas of culture, automation, lean, measurement, and sharing. So DevOps emphasizes a collaborative culture in an organization. So this shifts the operation more to the left, as in operation team does not, does more than just server management, right? So it uses same techniques as developers for their system work. Say for an example, their daily meetings, their Scrum, Agile, everything now DevOps also can be participated into inside the company. So it's a shifting of the culture, right? So then there comes is continuous delivery. So if you see the origin of the automation segment of DevOps is the continuous delivery. So it's like similar to continuous integration. And what is continuous integration? It's frequent code commit into the source control and runs automated builds again each code commit, and result is detecting error quicker, right? Similar to CI, continuous integration. CD is continuous delivery is Step one is exactly same as CI. Step two is, release code builds to the end user. And result is ship the software quicker to the end user. That is the motto of continuous delivery. And of course, we have ISC, that is infrastructure as code. That is the process of managing and provisioning your computer data centers resources through machine readable definition files rather than physical hardware configuration or manual configuration or any interactive configuration tools. Right? Through code, we are basically provisioning computer data center resources. So as you can see how development process has been evolved from 1980 to now. Uh, I have just mentioned DevOps and some DevOps IAC, continuous delivery and continuous integration. Now the next is microservice. Microservice and containers. These are basically the dynamic duo of cloud native architecture. So think of them as the building blocks of your software, modular and easy to manage, right? So, so what is microservice? So as you can see, this is a monolithic architecture. I'll not go very deep inside how microservice works, but this is more of a how we should adopt cloud native architecture. So I will just touch base on few high level idea of microservices, like how we do monolithic architecture, then everything is inside the same box, and now we break that particular service into microservice architecture. So basically microservice architecture is a software development approach where an application is built as collection of loosely coupled independently deployable services, right? So each service focus on a specific business capability of communicate with each other, and service through well-defined APIs or through database. They're communicating each other. So that is basically microservices. So I will discuss quickly on the case study of Uber, and it has been published on their engineering blogs few years ago, that how they have moved a architecture from a very tightly coupled architecture to a more microservice way when they have expanded worldwide, right? So this case study is very important to understand the importance of microservices. So if you see this picture, this was the earlier architecture of Uber. One second. Yeah. So if you see, a REST API is is present with the passenger and driver to connect with, and three different adapters are used with API within them to perform actions such as billing, sending emails, messages that we see when we book a cab, and then their data is stored into a MySQL database, right? So that was their earlier architecture, but they found a problem when they were expanding worldwide. This kind of frameworks introduces various challenges. Say for an example, all features had to be rebuilt and deployed, tested again and again when a single features they want to update, right? And then fixing bug becomes extremely difficult for Uber. They mentioned that in their blog, that it was extremely difficult in a single repository, as everything was inside a single repository, and developer had to change the code again and again. And another problem was scaling the features simultaneously with the introduction of new worldwide services, and it was quite tough to handle altogether, actually. So now they came up with this architecture after that, from there. So as you can see, the major change was, we can observe here in this diagram, is the introduction of a gateway, API gateway, through which all the drivers and passengers are connected now. Okay. And from the API gateway, all the internal points are connected, such as like passenger management, driver management, trip management, and other things from the API gateway. And the units are like individual separate deployable units performing separate functionalities. For example, if you want to change anything in the billing microservice, then you just have to deploy only billing microservice and don't have to deploy the others. and all the features were now scaled individually. That is, interdependency between each and every feature was completely removed. So, for example, we all know that the number of people, searching for cabs is comparatively more than the people actually booking a cab and making the payment, right? So this gives us an inference that number of processes working on the passenger management microservice is more than the number of processes working on the payments. So this is how they have evolved. So this was a good case study to analyze how they went from monolithic architecture to microservice. Now it was very easy for them to become cloud native. And then the last paradigm is the serverless. So let's talk about the serverless. This one is a little bit, misnomer, I'll say, because yes, there are still servers involved, but we don't have to worry about managing them by ourselves. That's the thing. So over the years, the serverless has gained much popularity, similar to the cloud native development. So it is now considered as one of the building blocks of cloud native application. So if you want to uh, build a cloud native application, think of serverless first. If not, then think of containers. So like that, the world has been evolved. So in this picture, if you see, this is one of the patterns of serverless functions. So there are many patterns available in the market, uh, like messaging pattern, command pattern, or fan out pattern. There are many patterns. So I have just depicted one command pattern over here. But there can be a different way of approaching serverless functions. So basically, in the serverless world, making things run smoothly is really important, right? It helps uses the resource better way, and it definitely saves money and makes everything faster. And using the right serverless pattern can really help and the development team to get the things done easier with better results. And as I said earlier, serverless functions can be found on platforms like AWS Lambda, Bluemix, OpenWhisk, and then Microsoft functions, Oracle functions, Google functions, etc. So I will quickly show a demonstration of a serverless function, how we should build a small API based application using cloud native approach. Hmm? So maybe I hope my screen is visible. Uh, Probably I will show what I am gonna do, what I intend to do. So basically, um, there is this is clients. This is clients. Then client is basically passing an object, which is, say, for an example, for the sake of simplicity, think about it as user object, and it has user ID. User name and something like user analytics. This is a big object, and now this object client is saving in our application. So earlier, what we used to do is we used to create a big service which will expose a REST API to so that client can interact with that REST API and post their user object in our system. Probably we had to create a service based on any framework or any language, and that has to be deployed in a HTTP container like Tomcat, and then we have to expose REST APIs using any REST API implementations like REST-AZ or Jersey or something like that. And then we have to create the business logic inside our application that to what we should do by when we get that user object from clients. And then we have to make a connection with the database, or maybe we have to create a queue publish subscribe model to post that user object to a server managed, our own homegrown managed queue, right? Right, any queue like application server managed queue. But the same thing, if I want to do it now in this today's world, what I'll do is probably I will create something called API gateway, and then I will have, so for the sake of this demonstration, I'll use AWS as the cloud, but that is not necessary. You may use any cloud service provider out there. The idea is to understand how cloud services work. So service provider offers services like functions, AWS Lambda, Microsoft Functions. It's not tied to AWS. The concept is cloud native, so being any cloud. So I'll use AWS Lambda over here, and the Lambda, what it will do is basically client will create this object. It will pass the object to API gateway, and API gateway then talk to AWS Lambda, and probably AWS Lambda, what they can do, it will process the request, it will spin up, it will process the request, and it will then um, post the request in a probably a queue. So there will be small DL queue. Will so what Lambda is doing is basically and this is actually inside another VPC. I'll say and the data is currently now there in the SQS. All the user objects are there in the SQS. Now there can be another services which can be used as a listener. Listener to the queue, and it can consume the user objects and then interact with the database to really post that particular object, store, persist in the persisting layer. So that is a very small application I want to build. So earlier, to build this type of application, it used to take time. We had to think about the framework, the language, and then we had to think how we should do the infrastructure level thing, how we should deploy the code, how it should be available for the clients, everything. Now with this cloud native approach, it is very easier to understand this kind of framework. So this is what I want to build, and if you see, I have already created. See, this is what I'll do is what I have created is I have created a Lambda function. So Lambda function, for the sake of simplicity, I have used Java program here, but it's not limited to Java program. Any programming language can be used here to understand how the AWS Lambda works. So here I have used a Java program, and I just wanted to show you how simple it is. So when you create an API gateway inside AWS, basically API gateway will give you an host name and URL, and also you can you can really create the path everything. So if you see, I have created an API gateway, this is the AWS Management Console, and from there I just I've gone into a API gateway service, and with few button clicks, I had created a API, it's a demo API HTTP gateway, and there, if you see, this is the host name of the API they have provided already, and I have created an integration with Lambda, and this is the path for me, demo API request handler. So in the Postman, what I'll do is I will use, or from browser or from any client application. What you can do is you can use this invoke URL. So I use Postman. As you can see, I have used this invoke URL and then slash demo API request handler slash demo API request handler. That's it. And it should be a post, since I have created it as a post, and the body should be as JSON format. I am passing the user ID, anything like 1, 2, 3, and username can be ABC. It can be XX, this is email. Okay, now what it will hit is it will hit in my Lambda function. Now let's see what I have done in the Lambda function. I have created a Lambda function called demo API request handler Lambda, and I have integrated the API gateway URL as a trigger, because Lambda function generally gets triggered with an event, and API gateway, it can be any event like API gateway event, S3 event, and SQS event, which is a queue event, anything. That event generally triggers the Lambda. So the idea is to not to go deep dive into the Lambda function now, but to understand how we are changing the development pattern over here, right? And see, inside the Lambda, what I have done is I have implemented a AWS SDK provided request handler method, and I am passing API gateway proxy request event object over here, and then I'm just overriding a method called handle request, and there I'm getting that event. From there, from that event, I'm just doing request.getBody to get the entire user object as request body, and I'm using Jackson's mapper object to parse that JSON to user model, which I have created here as user ID, username, user email, and a map here. Yeah, this is optional. You may not pass the user analytics map over here, and then with certain configurations, and then what I'm doing is after that I'm just posting that message from AWS to AWS Lambda to AWS SQS. I have created a queue, and there I'm just posting the messages so that you can see from the outside world, the message has now come to the SQS. It's very easy. It's few lines of code over here, and then what I'm doing is I'm just building this. This is a Maven project. I'm just doing clean and install the Maven projects. Build success. Now what I'll do is I'll just upload my code. This is a jar file just now got created at 435 with 11 MB of size. So that's it. My code is deployed into AWS Lambda. So now AWS Lambda knows what to do, because in the configuration I have mentioned which in the code I have mentioned which class to be hit. So this is the message handler class. I have given the package name and the method name over here, and I have mentioned the runtime as Java 21, so that Lambda can understand when it creates the execution environment. It understands what it has to run, whether it has to run JVM or something else. Lambda understands that now. Now what I'll do is So this request I have just modified it 123 ABC and accessdemo.com. I'm just clicking send. So you can see it is successfully sent now. It took certain time, certain amount of time, but it's successful now. And in the SQS, as it is successful now, you can see there is one message available in this SQS I had created earlier. And if you want to see the message, this was the message I just posted, right? So it is now there inside the queue, and any listener service can consume it, can process it, and do whatever it is, do whatever it wants to do with it, right? This so it's very easy, very simple. And now if you want to check the log, AWS provides a log. In not only AWS, any cloud platform service provides a logging mechanism, so that really you can stream all the logs. Here for AWS, it is CloudWatch log. You understand, you don't have to do any third-party logging application. You have to buy any logging application licenses. No, not required. Everything these cloud service providers are providing you. You just have to utilize it. Now, if you go to today's stream, you can see how much time it took. I have logged everything, right? So 398 millisecond to API interaction, and total time is 6 seconds. To send the message starting from the external world to the AWS SQS, it took 6 seconds. Uh, First time it takes more time because Lambda is basically there is a concept called cold start of the Lambda. Lambda is now it is warmed. So I'll probably in another session I'll describe how cold start works, what is warm start, cold start, everything. But for the sake of understanding now, just understand that Lambda was not warm. Lambda was sleeping probably, and when you wake up, Lambda now it is got wake up. And if you do it in the next time, now it is really fast, right? And you can see there should be 2 messages now. Yeah, there are 2 messages available here, as you can see. And the latest message also you'll see right now I just posted. And this was the previous one, and this was the latest one, right? And in the log stream also you can see, I just have to refresh it once, and you can see the next subsequent request took almost 136 milliseconds, nothing, very fast. First one took 6 seconds, second one took 136 milliseconds. So everything you can log basically. So starting from what is happening, how the requests are flowing through the entire series of system, everything you can log. So cloud service is that much simpler. So that is what I wanted to show you. And now probably I wanted to show another thing, which is so not only this, everything got simpler nowadays. Say for an example, machine learning model, running of the machine learning models, right? So earlier you really had to think about what infrastructure you need to spin up to run your particular machine learning model, because these machine learning models use huge GPU, CPU, everything, right? So those things right now you don't have to think about it. Say for an example, the introduction of AWS Bedrock. If you see, I'll quickly show you what is that. So you can see there are already predefined models are available. These models are large language models. So for generative AI, today's hot topic, generative AI, it is very much easy to plugged in your piece of thing into these existing models, existing LLM models. like A121 Labs and Amazon, Meta's, Llama, everything is integrated over here with AWS. You just have to access the request. Also, you can, plugged in your custom model as well, and you can fine tune your own model. You can do lots of things. You don't have to worry about the infrastructure thing. It is currently hosted in the AWS. You just have to worry about the understanding of your model, what it is doing. Or you can use the existing models. The cost is really per token based. As you know, what is token, right? So basically, I will show you. I have, you know say for an example, text, right? So if you want to select a model, I have already have a access for this model, Amazon Titan. So you can use it to understand what is this. Basically, maybe it's a text. You can just prompt it anything like Chat GPT that tell me a horror short story, and if you just run it, it will generate the story for you. Okay, and you can just integrate this with your API in your application. Like if you see the Vue API request over here, you just have to do this with your AWS CLI or in any language, Java, Curl, Python, any language. You just have to, this is your API request. With more security, you can provide API key as well. And then if you run through that, I mean, if you run this input through your code, your model output should be the same story, and you can output it inside a text similar to this. Now that much simple it is. In your app, from your application, you have to just do few API calls to really integrate the generative API in your application, and your application becomes Gen AI compatible applications now. So it's that much easy. The costing, the only thing you have to understand is what is how the costing is. These cloud service providers are really billing you per token based or per request based. All of those things you really have. That is your research part. That is the only thing you have to do, the self research, and rest of the things are very easy. So that much simple it is. Even no, I showed you generative AI. Today's AI topic is also very simple to understand and integrate with your application. Also you can do fine tuning, you can do embedding. There are a lot of concepts, right? Like tokenizing and embedding, and then you can do all of those things with AWS Bedrock, and you don't have to worry about the infrastructure. So uh, having said that, there are certain challenges definitely exists in cloud native architecture, and uh, that I want to tell you right now. Probably I'll again share my PPT. Yeah. So the challenges what I have seen is majorly on the very small startup or bootstrap startup. They are actually facing the challenges whether they should adopt cloud native or they should not adopt this approach. Uh, say for an example, you just you have just write a code or algorithm which is now being liked by many friends, many customers, and everyone is really happy and you are also really happy. Now you want to produce it as a service. So this is how a SaaS startup you can create, right? So you can create an algorithm, and people are liking it. They are saying that I will pay you money for your algorithm and let me use that algorithm. So this is how a startup forms. So now the next question will come into your mind is what tech thing you should use, whether you should use container, whether you should use microservices, what kind of database you should use, whether you should go to cloud native or not, whether you should do NoSQL or you should do SQL, all of those trending tech, whether you should adopt it or not for your startups, right? So there has been a debate. So what I have seen is like While cloud native approaches are, often found beneficial in most of the business cases for big organization, but there are still discussions, debate going on in early startups. Should you go with cloud native approach or while setting up your tech or not, right? Like containers, say for an example, containers fall perfectly in the category of it could be used sometimes, but it's probably not for, not going to be useful for very small startups. So the reason few say this is, because containers have amazing facilities when it comes to auto scaling, when it comes to complex deployment, when it comes to scheduling deployments, when it comes to managing a cluster. And none of these are actually very relevant for an early startup or very small size company, right? And another thing is cloud managed NoSQL. So NoSQL database are far better than SQL databases. Many says that, but many says SQL databases are far better than NoSQL database, right? You see, it depends on what type of use case it is. Some says it doesn't matter. If you have early startup and if you have really small size company, like 5 or 10 developers are using that, then it doesn't matter what kind of database you are using, right? So you might feel like, what do you see? It doesn't matter. What if it's a tech startup or something like that? See, in certain cases, definitely it matters. It matters. It makes sense to truly understand how the underlying database are running. But in most of the cases, you are providing a customer value for very small startups, right? So when NoSQL database would be very much useful, if you ask me, I'll say, when it comes to scale, when it comes to easy schema change, and there is no join in NoSQL database, right? Yeah, totally irrelevant for small startup. These all three categories. See, I mean, you have not more than thousand of customers. So why you need a scale that normal RDBMS will not be able to handle? Definitely, it will be able to handle. And also for easy schema change, you can always do alter table query. You can fire every now and then, or you can fire at night 2 a.m. and the alter table query. There will be a downtime for very few minutes. You have 1,000 customer, you just let them know that I have a downtime 5 minutes, and fire the alter table query. It will really save your cost, right? So, and then so you see, these are the use case specific, right? And number three is microservices. So, microservices have been under a lot of scrutiny recently for this early startup, whether they should adopt it or not. Like microservice is very useful, but the thing is that if you have a five developer working with you, then it doesn't matter whether you have separated 5 services, everyone is pushing the changes into same repository or not. It doesn't even matter, right? For the thing is that you might want to do cloud native when you are having 10,000 of customer, you have a huge set of users, then it perfectly makes sense. But for a small startup, you should be cloud ready. But my practical experience says that you should be cloud ready. Like, you should develop your things keeping in mind that in future it might grow, and then you should not do many changes to adopt the cloud native practices. That is the best practice to follow, cloud native adoption. And often we have seen these issues like monitoring security, lack of training, or the cultural challenges, or the complexity of cloud natives for very early and small startups. And they have in this survey, you can see the results of the survey. 40% of them are saying that these many challenges are we are facing if we adopt cloud native, being a very small startup, right? So there is certain challenges. Also, there is a challenge called vendor lock-in, obviously, right? You can, if you tied with AWS or GCP, then probably you have married with them, and if you want to change that, then you have to go with multi-cloud option, or what are the things you have to think about it. These are the typical problems you have to. The architecture, the architect of that organization typically thinks should think about these kind of problems when they adopt cloud native development for their organization. So yeah, this much I wanted to share for today. These are the sources I have also mentioned, and yeah, I'm now open for any question, answer related things. If you have any question, you can ask me.
Do anyone of you have any questions? Okay. I think that's it, Someshwar. Thank you for enlightening us on how cloud native makes a huge difference in software development and deployment. And thank you, audience, for your time and presence today. Let's continue to share the knowledge and connections we made. And we also have refreshments available at the back. Looking forward to meet you in the next Tech Container Meet. Thank you.
Thank you for having me. I have also mentioned my GitHub and LinkedIn, so you can always touch base with me in the LinkedIn. I'm active over there. And thank you for this opportunity. Thank you.
We'll also be making the presentation materials available in the meetup and the YouTube links. Please check it out. Thank you.
Yeah. Thank you.